Hi, it's Miss Townsend. Let's work on this question together. We need to rearrange these equations using algebra, like expand, if there's brackets, collect like terms, if that's possible, and possibly move terms from one side of the equation to the other. Our goal is to write a quadratic equation, which looks like this. So ax squared plus bx plus c equals 0. And of course, we've seen this before when we were talking about quadratics, that if the b happens to be 0, I still have a quadratic equation. So something in the form ax squared plus c equals 0, that's a quadratic equation. And similarly, if the c equals 0, and I have ax squared plus bx equals 0, that's also still a quadratic equation. So our goal, though, is to generally get everything onto the left side of the equation and collect like terms so that we have an x squared, an x, and then a constant term. So let's look at the first question. So I have 12x equals negative x squared plus 20. And I'm going to move everything to the left. I don't have any expanding to do. There's no brackets. So I'm just going to move my terms to the left and put them in order. So negative x squared would become positive x squared. Then I need to put the positive 12x term. And then the positive 20 is also going to move to the left. So when I subtract it, it becomes negative 20. And now I have that term written in proper quadratic equation format. All right, so let's clear some space. And we'll do the next question. So question B looks like this. And again, I don't see brackets, so I don't have to do any expanding. But I do have a bunch of terms on the left side of the equation and a bunch more on the right side of the equation. Sorry, just moving things around so I can fit it on the screen. So obviously I want to have all of my terms on one side because it has to equal 0. And that can involve collecting like terms as well. So I have 3x squared on the left and 2x squared on the right. So I'm going to subtract 2x squared to give me 1x squared. Then I have positive 5x and minus 5x. So when I move that minus 5x, it's going to add 1x. So now I have positive 6x. And then I have negative 60 plus 5. That plus 5 had to move. It becomes minus 5. So this becomes minus 65 equals 0. And now it's in proper quadratic form. Okay, let's clear some space and have a look at the next question. So question C looks like this. And I have x squared plus, and then I've got a bracket, a binomial x minus 7, and that whole bracket is squared. And then all of that equals the number 169. So I need to expand that bracket, because by expanding the bracket, I will get something that looks more like a quadratic, and it'll also allow me to collect some like terms. So I'm going to do that first. I'm going to square the bracket. So a binomial squared, oops, sorry, don't know why I wrote an equal sign. So this is now about to go here. So I'm going to square the first, that's x squared. I'm going to double the product. So the product is negative 7 times x. And if you double that, you have negative 14 times x. And then I'm going to square the last. Negative 7 squared is 49. And so now I've done the expand. So now I'm going to collect like terms and move everything to one side. So I've got x squared plus x squared. That's 2x squared. I've got negative 14x, and nowhere else is there a term with just x. So that's still negative 14x. Then I have positive 49. And on the other side, I have positive 169. So I'm going to subtract 169. 49 minus 169 is negative 120. And now it equals 0. So it's in proper quadratic equation form. Okay, so let's clear that away so we can have a look at the next question. So question D. So there's a lot going on. That's what question D is. So I like to write it out, even though it's written in front of me. I'm going to write it exactly the way that it appears, because when I write it, I'm focusing more on what exactly I'm given. On the left side, I don't have to do any expanding. It's in the wrong order, right? I've got 11x first and then negative 5x squared. So I'm going to have to change the order. And then on the right, I have two binomials multiplied together and then multiplied by 3. So I'm going to start over here. I'm going to multiply that stuff together. But while I'm here, I'm going to rewrite this in proper order. So it's still negative 5x squared, because that negative 5x squared isn't moving to the other side of the equation. I'm just rearranging it on the left. So I'm not changing that number at all. I'm just writing it first. Then I would write this one, which is positive 11x. So same thing. It's still positive 11x. I'm not moving it to the other side of the equation. And negative 18 is still negative 18. So on the right, personally, I like multiplying the binomials first before I multiply by 3. It just means I'm more likely to be able to do that without having to access my calculator, because I have smaller numbers. So I'm going to do x times x, that's x squared, and then x times negative 3, negative 3x, 2 times x, and then 2 times negative 3, which is negative 6. So I'm going to keep going, and I have to write both sides of the equation with the equal sign for proper math communication. So here, I could collect like terms. I mean, I should collect like terms, and I will collect like terms. But you can certainly multiply by 3 and then collect like terms. But according to Bedmas, we are supposed to do what we can inside the bracket. So I'm going to do that. Negative 3x plus 2x is negative 1x. And now I'm going to multiply by that 3. So I'll have 3x squared, and then minus 3x, and then minus 18. So now I'm going to collect like terms by moving the stuff on the right to the left side. And in case you're wondering about Bedmas, what we're actually doing when we move things from the left side to the right side is we're actually adding or subtracting those terms. So that's why I couldn't move something before I'd finished all the multiplication and collecting like terms required by that expand idea. So let's see what happens. This is negative 5x squared, and I'm going to move the 3x squared over, which means I'm actually subtracting 3x squared. So negative 5 subtract 3 is negative 8x squared. Then I have positive 11x, and on the right side I have negative 3x. So I'm going to move the negative 3x over, which means I'm actually adding 3x. 11x plus 3x is 14x. And then I have negative 18 on the left and negative 18 on the right. Oh, so when I move this negative 18, it's going to become plus 18. Negative 18 plus 18 is 0. So I don't actually have a constant anymore. I mean, I could write plus 0, but that seems like a waste of my ink. So all I have is negative 8x squared plus 14x on the left, and on the right equals 0. So let's clear the screen, and we'll look at the next question. Okay, so the next question is E. And so here's E, and again, I'm going to write the whole thing out, because when I rewrite a question without doing anything, it forces me to focus on what I'm writing. I see more of it when I take the time to write it. So that's what I have. So on the left, I have a binomial squared. So I have 2x minus 1 squared plus 2x plus 1 squared, and then I have equals 290. So on the left, I have some expanding of brackets to do. And don't forget the plus sign. Don't do that until you've done the expand. So I'm going to put a bracket here and put a bracket here and then say equals 290. So now I'm going to expand this binomial. So 2x minus 1 squared. So I'm going to square the first. So 2x squared, 4x squared. Then I'm going to double the product. So the product is negative 1 times 2x. So that would be negative 2x. And then if I double it, I would have negative 4x. Square the last. Negative 1 squared is positive 1. So I squared that binomial, and now I'm going to move on and square this binomial and write it in here. And a lot of the thinking's the same, it's just the sign that's different. So square the first, double the product is positive 2x. If I double it, I have positive 4x, and then square the last, positive 1. So I expanded those binomials. Now I kept them in a bracket, even though I can see now I didn't need to. But for example, if there had been a number out front of that bracket, so 3 times that binomial squared, now is when I would multiply that number in. But we didn't have that. So what I really have is just 4x squared minus 4x plus 1 plus 4x squared plus 4x plus 1 equals 290. So I have 4x squared plus 4x squared is 8x squared. Then I have negative 4x plus 4x. Well, negative 4 plus 4 is 0, so I don't have any more x. I have 1 plus 1 is positive 2 equals 290. So now I can make it equal to 0, which is, I'm going to subtract 290. So 2 minus 290 is 288. And now it equals 0. So this one's missing one of the terms, right? ax squared. I see that term. There's no bx term, but there is a c term. And that's fine. That's still a proper quadratic expression. Well, actually, it's a quadratic equation. So let's clear the screen, and then we can look at the next question. So I have question F. So again, I'm going to just copy the question so I can sort of be focused on what I might have to do, see what's going on. So on the left, I have a binomial squared, so I'll square that binomial. On the right, what's going on the right? I have a monomial times a binomial, so I'll multiply that. That's part of the bracket expand part. And then, there's also plus 28, which I'll deal with when I have to. So first, let's square that binomial. So square the first, 9x squared. Double the product. So the product would be negative 4 times 3x is negative 12x. So if I double that, I have negative 24x. Square the last, negative 4 squared is plus 16. Then I have an equal sign. So now I'm going to multiply 6x into the bracket. So 6x times x, 6x squared. 6x times negative 4, negative 24x. And I have plus 28. So on the left, I have a quadratic looking thing. And on the right, I have a quadratic looking thing. So now I'm just going to bring all those terms together on the left side. So I'm going to subtract 6x squared, add 24, subtract 28. So 9x squared minus 6x squared is 3x squared. Negative 24x plus 24x is no more x's. Yay! And then plus 16 minus 28 would be negative 12. So that is a quadratic equation in proper form. Bye.